Hi friends, I am Swati. I am a faculty member for the subject chemistry. So actually in the previous video we discussed about the concept of valency under the periodic properties. Now we are going to discuss about the next property, that is atomic radius. Atomic radius. This is also called as atomic size. Atomic radius or atomic size. So, how to define? First, what is the definition of atomic radius or size? So, as we know that total, according to the Bose atomic model, we know that the total positive charge is present at the center of the atom is called nucleus, and the electrons revolve around the nucleus in the well-defined path. That well-defined path we call as the orbital shell. Now, the distance from the atomic radius means the distance from the center of the atom, that is nucleus, to the outermost shell where the electron present. That distance we call as the atomic radius. I am repeating, atomic radius is defined as the distance from the center of the nucleus to outermost shell where the electrons are present. That distance we call as the atomic radius or size. So then what are the units? What are the units? Generally units, it is a distance. Distance units are, generally we use the meters and centimeters, and bigger unit is kilometers. But here we know that atom only invisible to us. Then the distance between the nucleus to outermost shell is very less. To measure such a smaller lengths, we are used picometers, nanometers, and the angstrom. Then 1 angstrom equal to 10 power minus 8 centimeters or 10 power minus 10 meters. 10 power minus 8 centimeters or 10 power minus 10 meters. Then next, how it changes in periods and groups. First we will discuss in case of groups. So in case of groups, like if you consider the first A group elements, what are the first A group elements? Those are the hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Then its general electronic configuration, I am writing only outer shell configuration. It is 1s1, here 2s1, here this is 3s1, here potassium is 4s1, rubidium 5s1, cesium 6s1, and francium 7s1. Now if you take the hydrogen, so the nucleus, the distance from the nucleus to first shell we called as the atomic radius. Then when we come to the lithium, the electron is present in second shell. Then from the nucleus to second shell we call as the radius. Then we know from when we come to the sodium, from the nucleus to third orbit we call as the radius. Then when we come to the potassium, then nucleus to the fourth orbit we call as the atomic radius. Now we can say that, so when we are going top to the bottom in a group, when we are going top to the bottom, the number of electrons increases. Then we come to that hydrogen, atomic number 1, lithium 3, 11, 19, 37, 55, 87. Then when we come to the, in a group top to bottom, atomic number increases. So as we know that atomic number increases, the number of electrons increases. So to accommodate this number of electrons, atom requires the more number of shells. So here when we are going from top to bottom, so the number of electrons increases. To accommodate that, the number of shells or orbits increases. That's why we can say simply atomic radius increases. Atomic radius increases in case of the group from top to bottom. So what is the Conclusion, in case of groups, top to bottom atomic radius increases. Then why it is increases? So when we are coming from top to bottom, atomic number increases. As a result, the number of electrons increases. To accommodate that number of electrons, number of shells increases. So atomic radius increases. Then when we come to the group, when we come to the periods, so if you consider the first, we never consider the first period. Then when we are going the second periods, then second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. When we come to the electronic configuration, 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, 2s2, 2p5, 2s2, 2p6, 2s2, 2p6. This is the atomic radius. That means you see that all the elements which are belonging to the period, the electrons are entering into the same shell. Electrons are entering into the same shell. Then we can suspect that is the atomic radius same? Yes. Yes, according to this concept what we learned, all the electrons are filling into the same orbit. You can guess it, the atomic radius is same. But there is elements when we discuss about in the periods left to right, that is lithium to neon, in general atomic radius decreases. In general atomic radius decreases. Why the atomic radius decreases? Why the atomic radius decreases? Here, if you consider lithium, 3 atomic number 4, 5, 6, 7, 8, 9, 10. So when we are coming to the left to right, the atomic number increases. The atomic number increases means we know that atomic number is defined as the number of protons present in the atom or the number of electrons present in the neutral atom. So here at left to right, atomic number increases means the number of protons in the nucleus increases. That is, we can say as nuclear charge increases. Nuclear charge increases. So as nuclear charge increases and these all the electrons enter into the same shell, nuclear charge increases and all the electrons enter into the same shell. So the attractive power of the nucleus on outer electrons increases. The attractive power of the nucleus on outer electrons decreases. So because of that increase in nuclear charge, this nucleus, here electrons are negative charge, nucleus is positive charge. This positive charge strongly attracts the negative charge. Due to that, this nucleus slightly pulling these negatively charged electrons towards itself. Because of that, its size slightly decreases, its size gradually decreases. So I am concluding that how atomic radius changes. Atomic radius is defined as the distance between the nucleus to outermost shell where electrons are present. Its units are meter, centimeter, picometer, nanometers and angstroms. Then in a group, top to bottom atomic size increases due to increase in atomic number. Then when we come to the periods, left to right, atomic radius, left to right, atomic radius decreases. Atomic radius decreases. Why it decreases? So here all the electrons enter into the same shell, but here the nuclear charge increases. So due to that, atomic radius decreases. Atomic radius decreases. So now in case of metals, we will speak about or we will discuss about metallic radius. In case of metals, there will be the metallic radius. What is meant by metallic radius? So in case of metals, each atom not bonded to other atom, but without a bonding, those metal atoms are very close to each other. So this is the nucleus of this atom and this is the nucleus of this atom. This distance we call as the internuclear distance. Half of the internuclear distance between the two adjacent atoms of a metal crystal is called as metallic radius. Half of the internuclear distance, this is the nucleus and this is the distance between the nucleus, this we call as the internuclear distance. Half of the internuclear distance between the atoms which are bonded through a metallic bond. Such internuclear distance we call as the metallic radius. This metallic radius only measured for the metals. Metallic radius is only applicable for the metals. Next one we have the covalent radius. This is the radius is measured for the atoms or molecules which are formed due to the covalent bond. So like if you take the simply Cl2 molecule. So one chlorine is bonded to the another chlorine through the covalent bond. So in case of if you take the chlorine molecule, this is one Cl2 molecule. This is another Cl2 molecule. So this is the nucleus of one of the atom of this molecule. This is the nucleus of another molecule, one of the atom of another molecule. So the distance between these two molecules. So the half of the internuclear distance between the two adjacent atoms of a covalently bonded molecules. The distance we call as the covalent radius. Half of the internuclear distance between two adjacent atoms of a molecules which are bonded through the covalent bond. Such distance we call as the covalent radius. Always covalent radius is more than the metallic radius. Then now we are going to discuss how radius changes when atom converts into ions. So now we are comparing the, now already you know that what are the types of ions we have. We have the cation, atom and anion. Now the comparison between the size when atom loses electron or atom gains electron. So we know that when atom gains electron, it converts to anion, that is negative charge. When atom lose electron, it changes to the positively charged cation. Like just first you will come to the cation formation. That is the example of like you take the sodium metal. When we are taking the sodium metal, we know its atomic number is 11. Its electronic configuration is 3s1. If you write the full configuration, it is 1s2, 2s2, 2p6, 3s1. So now if you consider that, so the distance from the nucleus to third shell we call as the atomic radius in case of this sodium. And it is having the atomic number means it has the 11 electrons and it has the 11 protons. Then when the sodium lost one electron, when atom lost electron, it converted to its ion. So when atom converts to its ion, no change in its atomic number. Then when we come to that, it has lost the 1 electron by the, actually it has 11 electron. If it lost 1 electron, it has 10 electron. No change in its proton, it has the 11 protons. So it has 10 electrons and 11 protons. That means which charge is more? Electron, negative charge is more. Sorry, electron, negative charge is less, positive charge is more. So how many units? Positive charge is more by 1 unit. That's why it is Na plus. It is Na plus. Now if you write the electronic configuration, it has the 1s2, 2s2, 2p6. So if you observe very clearly, now if Na plus ion, it has the lost electron only in the second shell. Then from the nucleus to second shell we considered as its atomic radius. Then in case of atom, it has the distance from nucleus to third orbit. When it comes to the ion, nucleus to the second shell. Then clearly is visible to is that the size is decreases. That means when an atom converts to its cation, its size decreases. So not only here, in case of here the shell decreases, but when we come to the other atoms, when we come to here that here 11 protons, here 11 protons, here 11 electrons and 10 electrons. So 11 protons can hold 10 electrons more strongly than the 11 electrons holding the 11 protons holding the 11 electrons. So here 11 protons, 10 electron. Here the nuclear charge is more. Nuclear charge is more. So due to the increase in nuclear charge, as we discussed earlier, as the nuclear charge increases, atomic radius decreases. Nuclear charge increases, atomic radius decreases. Then when we come to the cation and atom, which has more size? Cation and atom. Atom has more size than its cation. Atom has the more size than its cation. Then when we come to the anion, the just example we will discuss is chlorine. The example which we discuss is chlorine. We know atomic number 17. It has the atomic number 17 and electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. Now this is the nucleus and last electron is present in the third shell. The nucleus to the third orbit is called the radius for the chlorine. Radius for the chlorine. Then it has the atomic number 7. It has the 17 electron and protons are also 17. Then this chlorine gains 1 electron. When chlorine gains 1 electron, it has 17 electron. Then atom converts to its ion, no change in its atomic number. It has 17 atomic number. Electrons, it has 17 electron and gained 1 more electron. It become now 18 electron. And the number of protons, no change in its protons. Then if you come to here, 17 protons are holding 17 electrons. Here 17 protons are holding the 18 electrons. 17 protons are holding the 18 electrons. Here the nucleus charge decreases. Nuclear charge decreases. So due to decrease in the nuclear charge, then atomic radius increases. Due to the decrease in nuclear charge, atomic radius increases. And here 17 protons and 18 electrons, then negative charge is more by 1 unit. That's why we'll write Cl minus. Then we can say that, so when compared to the anions, anion has the more size than its atom. Anion has the more size compared to its atom. Then so when we come to the atom and anion, anion has the more size than its atom. Then a cation, then comparison, cation less than atom less than anion. So we have the two examples. Just compare the order of H, H minus and H plus. Then the order is cation, atom and anion. Cation is H plus, then atom is H and anion is H minus. Like in the same manner, I minus, I plus. Then here cation is I plus, I minus. This is the order of the cation, atom and anion. Then when we come to the isoelectronic species, isoelectronic species. Isoelectronic species. So what is meant by isoelectronic species? Iso means same, electronic, same number of electrons, species. So in case of chemistry, either atom or ions. Atom or ions we considered as the species. So what is the meaning of isoelectronic species? So either atom or ions which are having the same number of electrons, those we call as the isoelectronic species. Either atom or ion which is having the same number of electrons, that we call as isoelectronic species. So like if you consider the N minus 3, O minus 2, F minus, neon, Na plus, Mg plus 2, Al plus 3. Now if you see that nitrogen atomic number 7, it is gained, minus 3 means it gains 3 electron. Actually has 7 plus 3, 10 electrons. Oxygen number of atomic number 8, minus 2 means it gains 2 electrons. 8 plus 2, 10 electrons. Fluorine atomic number 9, minus 1 means it gained 1 more electron. 9 plus 1, 10. Neon atomic number 10, it has 10 electrons. Sodium atomic number 11, it plus 1 means it lost 1 electron. 10 minus 1, it is 11 minus 1, it has 10 electrons. Magnesium atomic number 12, it has the 12 electrons, plus 2 means it lost 2 electrons. 12 minus 2, 10 electrons. Aluminum atomic number 13, it has the 13 electrons, plus 3 means it lost 3 electrons. 13 minus 3, 10. So all these ions, it said these are anions, atom and cations. All these are having the same number of electrons, that is 10 electrons. So in case of isoelectronic species, as already we learned that anions are having the more size than its atom. So here N minus 3 has more size than O minus 2, then F minus. Isoelectronic species. What is meant by isoelectronic? Iso means same. Electronic means electrons. Species means atom or ions. So either atom or ion which is having the same number of electrons, those we call as isoelectronic species. Then N minus 3, nitrogen atomic number 7, it gains 3 electrons. Then total it has 10 electrons. Oxygen atomic number 8 and minus 2 means gains 2 electrons. 8 plus 2, 10 electrons. Fluorine atomic number 9, minus 1 means it gains 1 electron. 9 plus 1, 10 electrons. Neon atomic number 10. Sodium has 11 electrons, plus 1 means it lost 1 electron. 11 minus 1, 10 electrons. Magnesium atomic number 12, plus 2 means it lost 2 electrons. 12 minus 2, 10 electrons. Aluminium atomic number 13, plus 3 means it lost 3 electrons. Then 13 minus 3, 10 electrons. Then these all the ions and atom, all those are having the 10 electrons. Then these all set of atoms, we can call it as the isoelectronic species. So how can we compare the sizes of isoelectronic species? The simple one you remember, as in case of anions, isoelectronic species, for anions, negative charge increases, its size increases, and cations, positive charge increases, its size decreases. Isoelectronic species, as negative charge and anion increases, its size decreases. For when we come to the cations, isoelectronic species, as the positive charge and cation increases, its size decreases. This is the order of atomic radius in case of isoelectronic species. I hope friends, all of you understand this concept well. Then we will meet in the next concept in the another video. Thank you friends.